Question 5. A sample of radium has a weight of 1.5 milligrams and a half-life of approximately 6 years. How much of the sample remain after 6, 3, 1 years? Alright, so this radium, it's like a radioactive substance, right? And it's breaking down. And this half-life means that there'll be half of it left. It's sort of decomposing. It's unstable, highly unstable, and whatever makes up the atoms are falling apart. The pieces of it or whatever, right? So this half life means it's getting cut in half, and they say it takes 6 years for it to be cut in half. So let's think about this. We're starting at 1.5. I highlighted that in blue. They're saying we originally had a weight of 1.5 milligrams. This half-life, this is our rate of change. It's getting cut in half. And it takes 6 years to get cut in half. I'm thinking I'll change this to a green. Let's get 3 different colors going here. It takes 6 years to get cut in half. Sorry for the delay here. 6 years. Let's write our equation. How much of the sample will remain after 6 years? All right, so 6 years. They told us it takes 6 years. It'll be cut in half. A half-life means we cut it in half in 6 years. So let's start off by writing this out. Where do we start? We start at the beginning. Why would you want to start anywhere else? Let's throw that 1.5 in there. Here's our original weight of the radium. 1.5. It's blue because it's highlighted in blue up there. Can I make a little bit of a better 5? I'm struggling so much with my 5s today. That's a little better. All right, 1.5. And we can size it up a little bit. Make it a little fit in there nicer, huh? Okay. Now what's going on? Half-life. What is a half-life? It's getting cut in half. 1/2. And what happens after 6 years go by? What is our exponent? Boom. 1 6-year period has gone by. I'm going to come back to this. We'll talk a little bit more about the exponent of 1/6 when we get down to B down there, right? Because that stuff's after 2 years. So we'll save that for down there, part B of this question. All right, what is that equal to? This right here is equal to basically 1/2 to the power of 1 equals just 1/2. Anything to the power of 1 is just itself. So we got 1/2 of 1.5. I know that half of 15 is 7.5. So half of 1.5 is 0.75. Think of what you do know, right? If you know half of 15 is 7.5, half of 14 is 7, half of 16 is 8. So half of 15 is 7.5. But this isn't 15, it's 1.5. So they moved the decimal place 1 to the left. I'll move the place from 7.5, I'll move the decimal place 1 to the left right there. I'll make it simple. You won't need a calculator. Trust and believe. On the test, it'll be a little easier than that, I think. All right, let's see. That's it. How about 3 years? What about 3 years? All right, let's start at the beginning. We'll always start at the beginning. 1.5 is where we started. What's our rate of change? Half a life. We're getting cut in half every 6 years. Every 6 years. Every 6 years. We're getting cut in half every 6 years. And 3 years have gone by. How much of that 6 years passed? 3 out of 6. 3 is half of 6. 3 divided by 6 is 1/2. You could write 3/6. Maybe we'll do that. I'll put an extra step in here, just so make sure everybody's following along. 3 out of the 6 years passed. Why did I skip straight to putting 1 up here at the beginning? Why did I just go straight to 1? I knew that 6 years passed, but if I wrote it like this, Guess what one is? It's 6 over 6. 6 of the 6 years have gone by. So down here, 3 out of the 6 years have gone by. And I'll simplify that a little bit. I'm going to call it the 1.5 where I started. I got this half-life situation. We're cutting it in half. And what's 3 divided by 6? We've got 1/2. You can leave it like that in this part of the question, honestly. But, and we've seen in those previous questions that you want to know how to convert this to a radical. So let's do some radical math right now and show you how to write this out. I know you're going to dig it. 1.5 is where we started. And we got that 1/2. 1/2 down here. But we're going to use a radical. It's about to get pretty radical up in here. That right there. Now, where does that... The green... We got a pink 1/2 and a green 1/2. Oh, right now, I want you to look at the green 1/2. Where does that denominator go? We got 1 as our numerator up on top. It kind of goes out here. You could put it in there. It doesn't matter. They're the same exact thing. We don't really need to, actually, because anything to the power 1 is just itself. What about that denominator, the 2? We're going to need something. We're going to need to put that green 2 somewhere. Where does it go? The green 2 from the bottom of that fraction in that exponent that's right here. We're looking at the square root of 1/2. And now I don't want you to worry about what that is. Leave your answer like that. I want you to be completely confident that if you show me this right here, that's all you got to say. You know, say less. Right here. Here we are. That's all I want. Don't worry about what the number is. Show me you know how to write that exponent. And convert it to a radical. Here we go. One last thing. They want to know about 1 year. 1 year has gone by. Where do we start? Maybe we should start at the beginning. That sounds like a good idea. Start at the beginning every single time, please. What is my rate of change? I got a half-life. This thing is breaking down. There's only going to be half of it left after 6 years. But guess what? Only 1 out of the 6 years has gone by here. Guess where it goes in my exponent? Because this is called exponentials. And the variable goes up in the exponent position. Which color do we want? We're going to grab green. We're going to simplify. I think we're... Okay, now we're just going to convert it to a radical. We don't need to simplify that fraction anymore. We got the 1.5 milligrams was the original weight. And we're going to take this 1/2, convert it to a radical. And what's going to happen with this radical? How do we write 1/6 in radical form? Guess what? It's the 6th root. I think we're all getting good at this by now, hopefully. Hopefully. Now, I'll put some... We need to make sure we remember this is getting multiplied. It's 1.5 times the 6th root of 1/2. And do I want you to go plug this into a calculator and figure out some weird number with a bunch of decimal places in it? No, I could care less. This is what I want you to show me right here. And that'll be your final answer for that part. But stick around for part B. You're going to love it. Question 5, part B. That radium has a weight of 1.5 milligrams and a half-life of 6 years. Find a function f which models the amount of radium f of t in milligrams remaining in years. So you know what I did? I took this f of t. I wrote it right down here. What we've got is this function represents the weight of the radium as a function of time in each year that passes. And guess what comes into play? This right here is going to come into play right down here. That's what we want, basically. But we got to throw a t in there. Where are we going to put the t? So 1.5, we started at 1.5 milligrams. Ta-da. And we got that half-life. We're going to keep multiplying times 1/2 every 6 years that goes by. I got my stuff mixed up there. 1 half-life. And we saw that each year that goes by, it's only a 1/6 of the time that needs to pass. So guess what? I'm going to take t for years. And I had that in purple over there. T for time in years. But we need 6 of these years to go by before we can multiply by half. And there we go. That's our final answer right there. Piece of cake, right? Piece of radioactive cake. Radium is a secret ingredient.